Hey everybody, welcome back. So now that I am feeling a little bit refreshed, let's get these settings put into this thing and let's get our first print on it. Some things to note before I begin is first, I was tired the other night and I just wanted to get done, and I kind of did some things I shouldn't have, but you know what, that's what happens. I should have had smaller screws, smaller in diameter screws for here, and I didn't. So I wound up doing some damage. I printed another one of these little fan ducts off something I got off Thingiverse, and it's not 100% right either, but he did provide the fusion file, so I'm going to go in and fix it later. For now, it'll work the way it is. And I also should have put standoffs on my mount, because the brackets on me, the little tab that sticks out with the mounting hole on this cooling fan, part cooling fan, they are not flush with the back of the fan. So if you put a screw in and tighten it too much, you'll break them off. I haven't, fortunately, but nonetheless, I'm either going to have to sink some brass threaded fittings in it and leave them stuck out a bit, or I'm going to have to just put the standoffs as part of the print. So, but I can think about that another time. It is mounted and working, and I'm not going to yank it all apart to do that. So, also, I just want to note that nozzle, this watch case back remover tool, and this is the smaller of the two, it does not go small enough to take that nozzle out. So you may have to make your own tool out of an old sacrificial socket. Just grind enough material down to leave yourself 3 prongs sticking up, and that will take that out probably. I'm not going to do it right now because I'm not going to take it apart right at the moment. I still do not know what thermistor that is, so I'm just going with the one that, for now, the one that I had in the old one was this metal screw-in thermistor. I'm just going to leave the setting for that for now until I figure out what that is. I had to measure my offset from my nozzle to the probe, and I had to do it in both this way, and I have put those numbers in. And I'll show you where they are. Now, your version of Marlin may not have all of these settings available to you on the control panel. You may have to load up Pronterface and do it through Pronterface. I don't really want to. I've got all the settings here, so let's do it for here, and let's set the Z offset as well. I know you're probably not going to be able to see this very well. Let me zoom in on it a little bit. I can't show you the screen and the nozzle at once, but if you come to, and if also, to do this procedure, you're going to need to turn soft end stops off for the Z offset. So in mine, if I come to move axis, I can turn soft end stops off, and I've already done that. So I'm also going to move the Z up a little bit right now just to get it out of the way. So it's at plus any, you know what, that's good enough, 13.5 up. So another thing we want to do before we begin, and let me show you where I set those things. And like I say, you can do this via Pronterface. You can also do it via the firmware if you want to flash the firmware. Come to configuration and advanced settings and probe offsets, and this is where you can put in the distance from the probe to the nozzle. And I was very close. I was only a few millimeters off, like 37 to 40 and 5 from 7, so I was pretty close, but I did tweak that a little bit. Now what I want to do is I want to put I don't want to be in velocity. I want to make the probe offset to 0, and I've already been playing with this too, that's why there was a number in there, but we want the probe offset for this to be 0 to start out. And there we are with it at 0, and we want to store. Okay, you're going to need a piece of paper to do this, like this piece of note paper. And so now that we're at 0, and did I store it? I did store it. So now also, let me go back up to the nozzle, to the hot end here. Before you begin this procedure to get your Z offset in correctly, you want to make sure that your probe is mounted so that when the pin is deployed, it's below the nozzle, but when the pin is stowed, it's above the nozzle. So So that shouldn't need to be said, but there I said it anyway. So let's get on doing this. First thing we do, and also, don't know if you know, but I have the printer up to temperature close. I have the bed at 50 and the nozzle at 160. And I have the nozzle at 160 because I've already loaded filament in and I don't want it oozing while I do this. So first thing we're going to do, we're going to go to motion and we're going to auto home. Let me zoom back out. That's in. Now when you do this procedure, you want to be sure that when you use your paper, that your paper's under the nozzle, but not under the probe, because that will make it not work right. Okay, so with it homed, my Z is showing at 10. Well, so I can show you both at once. My Z is showing at 10. I want to bring it down to 0. So I'm going to go to motion, move axis, move Z, and I'm going to go by 1 millimeter increments to start. 9, 8, 7, 6, 5, 4, 3, 2, 1. And now I'm going to switch to 1 millimeter increments. And remember, soft end stops will probably need to be off. It's in my control panel. If it's not in yours, then you'll have to do it in Pronterface. So 0.8, 0.7, 6, 5, 4, 3, 2, 1, 0. Okay, we're at what it thinks is 0, and you'll notice I'm nowhere near. It would not print correctly like that. So what we want to do is we want to now move this down enough, down to where we have the correct amount. Now I'm going to go back to 1 millimeter increments because I know I'm going to be at least 3 before I'm right. So we're going to go -1. Let's throw caution to the wind and go to 2. All right, now I'm going to 1/10 of a millimeter increments, and just keep this going on until you get what you like. And you probably do it cold. I'm not sure how much difference it really is going to make. 3.5, 3.6, I'm getting there. 3.6, 3.7, 3.8, 3.9 maybe? 3.9 is a little tight. 3.8, 3.7, 3.6, 3.5. Okay, I'm going to go with 3.5 for now. So now that we know what we want our Z offset to be, we need to dial it in. So I am going to, just to be on the safe side, I am going to move my my nozzle, I'm going to move it up out of the way just so I don't have any accidents. And now let's go into we're going to go into configuration, and we're going to go into probe offset, which is now at 0, and I'm going to put it at 3.5. Felt a little bit loose, but then it wasn't changing, but nonetheless, I think that's probably a really good place for an initial test print. And if you're wondering where I learned this procedure, I didn't invent it. I got this off another YouTuber. I looked for that video so I could give him credit, and I just couldn't find it again. So if it was you, I'm sorry. If you're seeing this video, let me know, and I will absolutely add you into my my little description where I can tell you those things. Okay, so now that I have it, I want to store that. Store settings. And now I want to make sure that it's right. So let's home it again. And we're going to go motion and auto home. Okay, so let's get my paper back under, and we are going to go back to motion and back to move axis and move Z. And right now we're set at 13.5, so I'm going to come in 1 millimeter increments And I'm gonna, now it's 0. Instead of being loose, my 0 setting should be exactly what I want since I put my probe offset in. 2.5, 1.5, let's go down to 1/10 of a millimeter increments. We're at 1, 7, 6, 5, 4, 3, 2, 1, 0. Yeah, a little bit loose from where I'd like it, but again, I think that is a good place for an initial print. So let's just make sure my settings are stored one more time before I go on. So I'm going back to configuration, and my probe offset still says -3.5, and I'm going to go and just do store settings one more time to be sure. Let's try auto leveling it, and let's see how my auto level works. Okay, that was pretty good. I'm not unhappy with that. So let's do our first print and see what happens. I'm not sure what I have on this card, but let's try. I might have a test cube on it. I think I put that on it. Let's go look. And print from media. And I do not. Let me put like a 20 millimeter test cube on it. We'll try one in white, one in black, and then we'll start playing with the mixing. Okay, cross your fingers. I have black and white filament loaded in. This is going to be an XYZ test cube in 20 millimeters. And I'm going to print this one completely out of the white just as an initial test. And away we go. Okay, so let's take a look at our cube. Let me get the light over here. And it's not a horrible looking cube. It actually looks okay, printed okay. I've seen better looking cubes. I've seen worse looking cubes. Let's print it in black and see what happens. Okay, let's get it off and have a look at it. And yeah, I already knocked it loose. We get the light over because it is black and it is a little hard to see. That came out quite a bit nicer than the white one did for some reason. Yeah, that one actually came out pretty darn nice. Not sure why the white one didn't look as good, but oh well. So let's print another one. This time let's swap colors halfway through. Let's go 10 millimeters up in one color, swap to the other color, and let's see how fast it can change colors. I can do all that from the front control panel. Hang on. Okay, so what I have done, don't know how well you can see it here, but I have told it to use VTool 0 to 10 millimeters. Oh, lost it. Let me go that back again. So we're going to go VTool 0 to 10 millimeter when VTool 0 is the white. Then we're going to switch between 10 and 10.1 to the black. And let's see how that comes out. Okay, well that looks pretty good. Let me get it off of there. Well, that changed colors very, very, very quickly. There's hardly even a single line of gray in that part. Now, while that is nice if you want to change colors from one to the other very, very quickly, it does not, I'm not really sure that bodes well for a nice mixture, because that fast of a color change tells me that the mixing chamber might not be as big as I had hoped for. In fact, may actually be smaller than the one on the original A10m heating mixing chamber. Anyway, you know what, let's try next. Let's print one that does a gradient from 1mm to 19mm, and let's see what a gradient looks like. Okay, so this was a gradient from 2mm to 19mm, and you'll see some of the issues that I've had in the past of these things not giving me the same color exact on each side. Say for example, this Y side, it's very white at the bottom and then it turns black almost immediately, while the X side is a decent gradient. The Y side stays light colored most of the way up and then turns to black. And then, of course, the bottom and the top are completely white and black, which is what it was supposed to be. I also do want to note that I did wind up flashing the firmware, because I found out that the thermistor in this that's supplied with this Hotend is the NTC 100K, and it should be number 5 in Marlin, and I had number 11 for my old. So I did flash it and change that. Didn't seem to make a bit of difference. But next thing to try and last thing to try is a pure 50-50 mix all the way through. So let's do that next. Okay, so here we go. So this is a 50-50 mix all the way through. And get the light back over here. And you can see the Y side is almost black. Well, this Y side is almost black. That Y side is, I wouldn't call it white, but it's definitely a light gray. This X side is probably the best, the best representation of. And yeah, and here is here is something I printed off the old Hotend. Let me get it far enough away from the camera. This was the lid to that case prep thing I made. I made this on the old Hotend, and this was a 50-50 mix of white and black. And you can see I got something very similar. So it is, in that regard, it is no better than the original Hotend. So there you have all 5 pieces I printed with the new BigTreeTech ZSYong 2-in-1 out mixing Hotend, from white to a half black, half white, to a gradient, to a 50-50 mix, to all black. So what are my thoughts on this Hotend? Well, if you have a Geeetech A10m and your original Hotend is fine, it's fine. This really is not significantly better in my opinion. While it does work well, it is not really any better than the Geeetech Hotend for mixing colors and things like that. It does change colors very, very quickly, which I like, but you know what? The original Hotend wasn't bad for that either. Now, if you're trying to convert an existing single filament printer, you can use the Geeetech Hotend, or you can certainly use this one. Mounts are available on Thingiverse. I think my mount would work on the standard A10, might work on a couple of the other Geeetech printers. Doubt it'll work on an Ender 3, but who knows. I'm not going to yank one of my Ender 3s apart to tell, but there are mounts for this Hotend for the Ender 3, and probably a couple other printers as well. It does work well. It is well made. I really have no reservations about recommending it, other than the proprietary nozzle that you need a special tool to get out. That is really its biggest drawback, and BigTreeTech could have eliminated, at least partially eliminated that drawback by providing a tool with the kit, and they didn't. But anyway, I hope you guys liked this video. If you did, please like and subscribe, hit notifications, use my affiliate links, and I'll catch you the next time. Bye for now.